You may have heard in the historical introduction to the Timken Company how the design principle of the tapered roller bearing helped overcome the binding effect of friction as horse-drawn wagons turned corners and the weight pushed outwards as well as downwards. This fundamental design principle is still the single most important feature of the tapered roller bearing. The main reasons why the tapered roller bearing can solve so many problems for a designer are its ability to handle both radial and thrust loads in any combination. For a given bearing size, it provides a much higher total load carrying capacity. Its separable raceways allow adjustment of bearing internal clearance and help with installation. A choice of mounting arrangements to suit the loading aspects of an application. And lastly, a choice of taper angles to cater for different load combinations. All these features add up to optimum bearing system performance for any application with minimum size and cost. This means more cost-effective design and manufacture of original equipment, as well as reduced maintenance and longer life. Tapered roller bearings are available in many forms, but at the heart of the basic construction, there is a single row bearing, as shown here. Conical rollers run in inner and outer races. There is also a cage, whose main function is to space the rollers evenly around the races. The tapered geometry is one of its most important features, as it enables the bearing to carry both radial and thrust loads in any combination. But unlike other bearings, the tapered geometry produces both true rolling motion and self-alignment of the rollers, and therefore assures full line contact, regardless of whether the load is radial or axial, or both. The taper creates a small seating force which holds the large end of the roller against the rib of the inner race, which effectively maintains the rollers in constant self-alignment. To summarize, the tapered roller bearing can cope with both radial and thrust loads. It achieves true rolling motion with full line contact and self-alignment of the rollers on the races. It generally offers a higher total load capacity for a given envelope size than other bearings. The cone, inner race, are separable components, so they can be moved axially at installation to give the exact clearance specified by the designer. This adjustable clearance is probably the most important feature in achieving the best dynamic operation and optimum life for a bearing system. When a radial load is applied to a tapered roller bearing, the line of action of that load is offset by the angle of the bearing. This is more commonly known as the effective center. This has two important implications. First, the requirement for the single-row tapered roller bearings to be mounted as opposing pairs, so that the bearings are mirror images of each other, and any force that tries to separate either bearing will be opposed by the other. Furthermore, this offsetting effect can be placed either way round to bring the effective centers closer together, to increase rigidity for a centrally applied load, as with this spur gear. This is called direct mounting, with the small ends of the rollers pointing outwards. Conversely, with the small ends pointing inwards, the effective centers are wider apart, and the shaft is stiffened for an overhung load, as in this pinion gear. This is called indirect mounting. Secondly, the angle of the raceways can also be varied to suit particular loading characteristics. For example, shallow angles for predominantly radial loads, and steep angles for mainly axial loads. But what does all this mean to the engineer in practice? Let's return to the subject of adjustable clearance. The tapered geometry and the fact that the inner and outer races are separable components give the tapered roller bearing the ability to be adjusted. This allows both the inner and outer races to be moved axially at installation to give the optimum clearance between rollers and races. To understand why this is so important, it's necessary to look more closely at how the bearing copes with the loads imposed upon it. The part of a bearing's raceway where the rollers support the external load is known as the load zone. If the load zone is small, then only a few rollers work. If it's large, then more of the rollers support the load. Bearings can be assembled with varying amounts of internal clearance, usually called end play. With zero internal clearance, 180 degrees of the race and half of the rollers carry the load. With slight internal preload, the load zone is spread around the bearing races so that more rollers carry the load. It's important not to preload the bearings so heavily so as to overstress the components. Ideally, the aim should be to have the bearings running with a very slight preload between the rollers and the two races. This ensures that the load is spread over a larger number of the rollers and that there is no internal clearance to cause sloppiness in the bearing assembly. This can be a big advantage for many applications, for example in gearboxes, to ensure closer gear meshing and quieter operation. In practice, of course, the pre-adjustment of a tapered roller bearing at assembly must take account of dynamic changes that can occur when the equipment is put to work, such as temperature changes that result in the expansion and contraction of bearings and other parts as the machine warms up. Timken application engineers are always on hand to help analyze such factors and propose optimum bearing selections, together with advice on fitting practice and adjustment. The essential point here is the bearing's inherent ability to be adjusted for optimum performance and lifespan for every single application, which in turn means optimum load, speed and torque for a chosen bearing specification. This often means a less expensive, smaller bearing for a given duty without any loss of load or speed performance. What about the basic performance characteristics of tapered roller bearings compared to other types? The catalogued ratings of the bearings are based on the industry standard L10 life. This is calculated by a formula which is based on load rating for a given number of running hours at a specified speed. In the case of Timken tapered roller bearings, this is 3,000 hours at 500 RPM. This standard catalogue rating is then modified according to the demands of a particular application. For example, if the speed is doubled, the life is halved. But if the load is doubled, the life is reduced by a factor of 10. For other modifying factors, such as misalignment, lubrication, and operating temperatures, the Timken company publishes formulae and data enabling life calculations to be made on specific applications. In broad terms, the tapered roller bearing has a better load-speed performance for its size than any other bearing type. For instance, it can carry up to 2.5 times the load of a ball bearing of the same size, the equivalent of 21 times the lifespan. It can take loads of any kind in any combination, which is a characteristic no other bearing has. The speed capability of the tapered roller bearing is comparable to other types, though for very high speeds it may be necessary to make special provision for improved lubrication. The tapered roller bearing is more tolerant than most other bearing types to misalignment, and with its inherent adjustability, the effects of temperature and lubrication can be allowed for when setting the bearing. All in all, the tapered roller bearing can offer performance benefits and cost savings in practically every field of application. in wheels and automotive transmissions on cars and trucks, off-highway plant and machine tools, on railway transmissions and axles, turbine wind generators and robots, domestic appliances and mining plant, the landing wheels of Concorde and the US Space Shuttle, and on industrial machinery of all kinds. The Timken Company, winning the battle against friction.